Hello students, in this video I will be using the concept of annuities to analyze the impact of the amortization time in the periodic payment of an annuities. The problem says Daniel purchased a condominium apartment of $690 with 25% down and monthly payments amortized over 25 years. If interest is 4.5% compounded monthly, A, what is the size of the monthly payments? So what will be the size of the monthly payment if we have this interest and the amortization time is 25 years? B, if the amortization period is 20 years, what would the payment be? And finally, what is the cost of financing in each of the previous situations? So what will be the cost of financing when we have 25 years of amortization, or what happens if the amortization period is 20 years? So the situation is obviously the following. So we have a time that could be 20 or could be 25, and we are going to be making payments of an amount that happened at the beginning. We are paying a loan. We have an amount that we have financed at the beginning, and we need to pay this in periodic payments. In each of these payments will be included payment from the principal that you owe and payment of the interest. So what will be the difference in these payments, and what will be the difference in the cost of financing depending on the time? So that is what I want to illustrate. So what will be the present value anyway in whatever situation is the amount that you finance. The finance amount is the cost of the condominium minus the down payment that you made. So this is an amount that you have not financed. So for that reason, at the beginning, to know this AN, we need to subtract the down payment. You are not going to finance that. The present value will be 690,000 minus the amount included in the down payment. So that will be minus 25% of this 690. So get a calculator to know what is actually the finance amount. 690 minus 0.25 multiplied by 690,000. So the answer is 517,500. So this is AN. And I need to pay this AN plus interest with these payments. So let's answer this situation. What will be the size of the periodic payment if the time is t equal 25? We know AN. We know also the interest, that is 4.5% compounded monthly. So let's type here that the nominal rate of interest will be 4.5%, and this will be compounded monthly. So we need to compute the total number of payments, but the total number of payments now in this case will be 25 times 12, will be 300. Good. So this is the number that you are going to use in the formula of the present value to compute the payments. Obviously, you are going to compute the payment, but you need the formula of present value because we know the present value in this problem. So we use the formula of present value, and we are going to solve for R because R is the question. So cross multiply here and find that R will be equal to I times AN times the present value of the annuity divided by this factor. So make a substitution. This I is 0.045 divided by 12, and this N here will be 300. The AN is 517,500. Anytime that you have a down payment, the present value will be the cost of the loan minus the down payment. Okay, let's see. Making the substitution, R will be this. And using your calculator now, this 0.045 divided by 12 multiplied by 517,500 divided by this factor. In a previous video, I explained how to use your a scientific calculator to compute this. Okay, do that, and the answer is 2,876.43. So we know that the size of the monthly payment, if we are paying this in 25 years, will be $2,876.43. So that will be the answer of the first question. Question B will be the same, but now when the amortization period is 20 years, when all this will be 20 years. So let's answer this second question. So everything will be the same. We are going to be using the same formulas, but the only difference is now that t will be equal 20. So when I'm finding n, I'm going to multiply 20 times 12. This is 240. So let's type it here, n equal to 240. We are going to do the same. We are going to substitute everything again, but this n will be 240. So when I make the substitution, I found that I put here 240. I use the calculator in the same way. 0.045 divided by 12 multiplied by 517,500 and divided by, open bracket in your scientific calculator, 1 minus, open another bracket in your scientific calculator. If the brackets in the scientific calculators are all the same. It's not like when you are typing that you have square bracket and round bracket. No, in your scientific calculator all the brackets look the same, but use it. 1 plus 0.045 divided by 12, close bracket, to the power negative 244. Be careful with the key minus in your calculator. Is the key that changes the sign. It's not the minus of the operation subtraction. No, it's the minus that is at the bottom usually of every calculator for changing signs. Close the bracket and press equal. So I found that the amount is bigger. It's 3,273.96. So the size of the monthly payment that will repay a mortgage of this in 20 years is $3,273.96. Now we can answer the third question. What is the cost of financing in each of the previous situations? We know how much you pay every time you pay. We know how many times you pay the amount. So you know the amount of the payment and you know the number of payments. Use it to know actually how much you have paid. Okay, for answering question C, what is the cost of financing in each of the previous situations? In the first situation, the size of the monthly payment that will repay a mortgage of $570,500 in 25 years is $2,876.43. The cost of financing is actually the interest that you have paid. So compute the interest. In 25 years, remember there are 300 monthly payments. So the interest will be equal to n, so the number of payments, times the payment, the amount of payment, minus the financed amount, so the present value. So it will be 300, number of payment, times 2,876.43 minus the present value that was 517,500. Make a substitution and use your calculator. So that gives you that you paid an interest of $345,429. That means that actually the interest that you pay is more than the half of the initial cost of the house. $345,429. Okay, so that will be in the first situation. This is the cost of financing if you pay or you amortize your debt in 300 payments in 25 years. In the second situation, when you pay in 20 years, remember that we get that the payment was $3,273.96. So in 20 years, you are making 240 monthly payments. So you are going to do the same to get the interest. Multiply n times r, so the number of payments, times the amount of payment, minus the present value. So always the interest, when you have a problem that involves present value, the interest is actually in the payments. It's different when you are saving money. If you are saving money, the future value will be bigger than the actual contribution. So if you are saving, the interest will be future value minus n times r. Now, in this case, it's the opposite. Will be n times r first and then the present value. Okay, make a substitution. 240 times the payment that was 3,273.96 minus the amount that was financed, 517,500. You make this and you get that the answer is 250.40. So the cost of financing is much lower. It's just 278,250.40. These two situations answer the last question. Thank you.